You know, keeping up with defense technology, it feels like it's moving at lightning speed, doesn't it? It's tough to stay on top of it all, which is exactly why we're here today. We're going deep on lethal unmanned aerial systems, LUAS for short, and specifically how the U.S. Army is tackling the development of these capabilities. Yeah, our information today comes straight from a U.S. Army article. It's titled Lethal Unmanned Aerial Systems, Safe, Reliable, Lethal Armaments Capability at Every Echelon. Came out July 2nd, 2025. Authors are Daniel DiMartino, Anthony Sebasto, and Eric Cole. So our mission really is to pull out the key insights from this piece. We want you to understand how the Army's trying to get these LUAS capabilities out there faster, cheaper, and crucially, safely. Okay, let's jump in. The U.S. Army Combat Capabilities Development Command, that's DEV Combat, their armament center, they've been doing R&D on lethal stuff for decades, right? But this article really positions LUAS as the cornerstone going forward. Why now? What makes them so central?
Well, a big takeaway from the article is the Armaments Center's main goal: get these LUAS capabilities to soldiers faster and, more affordably, and they're not starting completely fresh. They're taking their existing design processes, their safety standards, things they've honed over decades, and applying them here. It's more about adaptation, not necessarily a total invention.
Right, adapting what works. That makes sense. So it's not a complete tear down and rebuild, it's building on a solid foundation. That sounds like a smart way to get speed and safety. Okay, so building on that idea, the article talks about something called the Picatinny Common Lethality Integration Kit, CLIK. They compare it to the Picatinny rail, that standard rail on weapons for attachments. So what's the problem CLIK is actually solving for these drones?
Yeah. The CLIK tackles a really practical problem. Basically, it standardizes how everything connects: the physical attachment, the power, the data network, and, importantly, the safety controls between the ground station and the drone carrying the weapon. Without something like this, you'd have to figure out a unique integration for every single combination of drone and payload. That gets expensive fast and leads to what they call vendor lock.
Vendor lock? Yeah, I think we've all run into that with tech somewhere. You're stuck with one company's system, can't easily switch or mix and match. So CLIK pushes back against that. What does that mean for the companies actually building this stuff?
But for industry. Oh, it's huge for them. Havanjot Singh, who's the acting exec director over at the Armaments Center's Weapons and Software Engineering Center, he says CLIK, quote, ensures a rigorous yet flexible process for evaluating, qualifying, procuring, and ultimately fielding safe and effective weaponized UAS payloads. So when the Army asks for a new capability, they just provide the CLIK technical specs. That means industry can just focus on making the best possible lethal payload, not get, totally bogged down trying to figure out how to hook it up each time.
Ah, okay. So it lets them focus on their specialty.
Exactly. It's actually pretty fascinating how much efficiency that unlocks.
All right, so CLIK is the universal adapter, the standard plug, so to speak. What are they actually plugging in? Let's talk about these modular lethal payloads.
Right. So the idea here is versatility. The article mentions they're designed to work in a couple of ways. Some are for one-way attack missions, the drone doesn't come back. Others are on UAS that can drop munitions and then return. And the key thing is, several of these payloads have already been tested out with actual Army units. They're basically ready to go.
Ready to go. That sounds good for rapid fielding.
Yeah.
Can you give us an example? What's AUDIBLE?
AUDIBLE. Yeah, that stands for Armament UAS Delivered Immediate Battlefield Effects. It uses these quick change adapters so a drone can safely drop munitions the Army already has in inventory. Like the article mentions the standard M67 hand grenade.
Huh. So just using existing grenades but delivering them differently.
Precisely. It's a smart way to leverage existing assets, right? And they say it's a concept that can be scaled up for lots of other munitions too. It really fits that theme of using what you've got.
Clever. Okay, and then there's another one mentioned, Shank. It used to be called Project Shiv, apparently. What's its role?
Shank is more for those one-way missions, using first-person view, FPV. It takes an existing warhead type, an explosively formed penetrator, which is really good against armor, and packages it with an architecture designed for safe target engagement.
FPV, so the operator sees what the drone sees right up to impact. And Shank was part of a big test recently.
Yeah, a real milestone. The article highlights the first live-fire training exercise with FPV drones using Shank. It was back in February 2025 over in Germany at Grafenwohr. They partnered with the 7th Army Training Command and the 173rd 3rd Airborne Brigade.
Real soldiers, real training.
Exactly. And Anthony Sebasto from the Munitions Engineering and Technology Center, he kind of summed up the philosophy behind things like AUDIBLE and Shank. He said, not everything has to be high-tech solutions. Existing technologies can be integrated to provide a new capability, driving more affordable solutions for the warfighters.
Affordable and fast, by using what's already developed.
Makes sense.
Okay, so we have the standard connection with CLIK. We have these modular payloads like AUDIBLE and Shank. But what about actually hitting the target accurately? What tech helps with the precision and control side?
Right, that's crucial. So they talk about Gunslinger. This is a fire control system, government-owned, that they're adapting specifically for LUAS. Its job is basically to make sure the droppable munitions or direct fire weapons hit where they're aimed with much greater accuracy.
A fire control system.
Yeah.
So, like, the brains behind the aiming, does it help in the drones moving?
Yes, exactly. It's built using a modular open system approach, again, that theme of avoiding proprietary lock-in, and it constantly calculates the impact point. So even if the drone is maneuvering, Gunslinger helps keep the aim true.
Okay, so better aiming. What about the things that go boom themselves, the warheads?
Yeah, they're working on that too. They're applying existing proven warhead designs where it makes sense, but also developing new ones optimized specifically to counter, say, enemy drones. And a really critical piece here is safety. They're developing a safe and armed device that meets a specific military standard, MIL STD 1316, for use in this UAS environment.
MIL STD 1316. What does that compliance mean in plain English? Why is that important?
It's basically a very rigorous safety standard. It ensures the fuse, the part that makes the warhead detonate, won't arm accidentally, during handling or flight, and will only function exactly when commanded. It's a non-negotiable safety requirement. Sebasto again points out the Armaments Center is a, quote, world-class warhead and fuse developer, and often industry ends up using their designs because, well, sometimes there just aren't other options that meet these strict standards.
So serious focus on safety and reliability there. We've covered droppable munitions, advanced warheads. What about actual guns mounted on drones?
They mention that too. They've developed a small 5.56 millimeter direct fire weapon. It's designed with low recoil, specifically so it can be mounted on a UAS. Comes with its own fire control, meant for hitting specific targets from a standoff distance.
And not just specialized drone weapons.
Right. They're also taking fire control systems developed for soldiers on the ground, the small arms fire control systems, and adapting those directly for UAS. These are small, lightweight, and packed with features like aided target recognition, better target tracking, even aim assistance.
Wow, okay. That's a lot of different pieces. The interface, the payloads, the fire control, the weapons themselves. It sounds incredibly complex to bring all this together quickly. What's the key factor making this rapid development and integration actually happen?
The article really stresses the role of partnerships, specifically partnerships between defense and industry. They talk about cooperative research and development agreements, CRIADAs. These are formal agreements set up between the Armaments Center and the companies making the drone platforms and the companies making the lethal payloads.
Gradius.
Yeah.
How do those help?
They basically create a framework for collaboration. It allows for open technical discussions, sharing data, mutual testing, and experimentation. The article gives the example of the Picatinny CLIK industry partners were involved early on, providing feedback on the specification, which helped make it better and more practical from the start.
So it's not just the Army dictating requirements, it's a back and forth.
Exactly. It sounds like a genuinely collaborative effort, which is probably essential for moving this fast.
If you had to boil it down, what's the core message about how the Army is approaching LUAS based on this article?
I think the core message is that the Army's DVCOM Armaments Center is moving fast on lethal UAS by being smart about it. They're using standardization, like with the CLIK interface. They're focusing on modular payloads, some using existing munitions like AUDIBLE, others more specialized like Shank. They're enhancing precision with things like Gunslinger fire control and advanced warheads. And, maybe most importantly, all of them is built on strong partnerships with industry. The ultimate goal seems clear. Deliver these capabilities reliably, safely, quickly, and affordably.
Standardization, modularity, precision, and partnership. That paints a pretty clear picture. Okay, that brings us to our final thought for you, the listener. The Army is putting a lot of emphasis here on integrating existing technologies, existing munitions, existing warheads, adapting existing fire control onto new platforms to get capabilities faster and less expensively. Okay, So, what might this suggest about the future of military innovation? Is the cutting edge primarily about brand new breakthrough inventions? Or is it becoming more about the ingenious application and integration of technologies we, in many cases, already have? Something to think about.